Hello class, it's Dr. Mike here. So we're going to take a look at logical volume management, or LVMs. So this is really the common way that disks are sort of used now. Even at today's, you can install a laptop or desktop. LVM is pretty common. So what is it? We'll take a quick look at what it is, and we'll create, and we'll actually go through a process of growing a partition. So, or some LVM. So again, we saw before, traditionally, you partition a disk out with the partitions. You create a partition for dev, or sorry, for temp, or one for home, and so you do these with SD, A1, 2, 3, and so on. Well, what happens if I create /home and I give it 10 gigabytes from SD A4? Now 5, we'll say. So SD A5 has filled up. My capacity of my users has grown more than I expected. The amount of files they're creating, the large size of the files has really to the point where I can't even manage it. So I would need to, of course, bring the system down, unmount that disk, create a new partition, and then remount home to it with a larger partition. And of course, then copy all the files over. And anytime you get into copying large amounts of files, there's always something that can happen. So LVM really is the answer to this. It is logically managing volume. So we'll see what this is in a second here. It has some other things too. You can add or remove disks without downtime, and you can create snapshots or backup of live file systems. So it has a lot of things it gives us. But for now, we'll keep it simple. So what we have is we create a series of physical volumes. So, and what we have here is with physical volume, or usually as a PV. We take those can be disks, so, or partitions, but let's just say disks. So I go out, I buy 3 hard disks. Here's SDA, A, B, and C. I take these two and add those to a physical volume, PV group. And then I add C to another one, or I leave it. I leave it as backup. C might go to PV and another physical volume group. And then maybe I buy a third disk later, D. So these PV groups, and I'll take this PV group, which encompasses all these disks, in this case these two. And these can be separate sizes too. They don't have to be the same size disks. This is not like RAID. They can be several different size disks we have here. So this is a 1 terabyte, and this is I go out and I get a 2 terabyte here. So traditionally, we'll probably have about 3 terabytes of storage with this physical volume group. And from here, I create logical volumes. So I take a chunk of this. I say I want 1 terabyte for a logical volume, and I want 500 gigabytes for another logical volume. And then that gets formatted and attached to like /home, for example, and so on. And they look like normal partitions after that. Cool part is, let's say it's /home. All right, /home fills up. So instead of having to go through the process of finding some more disk space or creating a new partition, formatting it, remounting, and copying everything over, I can grow this. I just grab some of the free stuff from this volume group, and I grow from the 500 to maybe now 1 terabyte. So that is definitely an advantage there. So again, advantage, we can resize live file systems. So let's actually go through, we'll talk about the commands here real quick, but we'll show these here. We'll actually walk through it. We have a series of commands though. PV create, BG create, and LV create. And we'll also see there's other things we can use. There's display, BG display, PV display, LV display. We'll see this here when I do it live. There are GUI tools that will do this. Red Hat and some other tools have some ways to admin. I won't go into that here. Use those as you see fit. The last thing too when we're done is we'll see this dev mapper. So what happens is volume groups are handled by this dev mapper. And so we'll see this used a lot when we reference a volume group. We'll see that here in a second. But there's some sort of linkage here, and the underlying infrastructure of logical volumes runs on this dev mapper. So in case, well, the first step though is actually need to create our file systems. So we'll do this as normal. And just like before, we'll see we do this with fdisk. So again, I'm root. Make sure you're root, not who. Make sure you're root user. And so here we have SD splat. So here we have some file systems. There's dev SDBC. There's that one I created this SDC one earlier on in a previous lecture. But we'll use SDB. So let's do an fdisk-l. And we have dev SDB here. It's 21.5 gig. It's empty. There's no partitions. So we'll go and use that as our test case here. So we do have to go back and do our fdisk on dev SDB like normal. Again, you can see there's no partitions. And we're going to create some new ones. So N for new. So we'll do a primary first, 2048, again, taking the defaults. These are really small. Let's do a plus 100 megabytes. Again, this is normal. It's not normal. Make it small for this demonstration. You would probably have a lot larger, even an entire disk as one partition that's used for LVM, but for now, we'll create some partitions here. We're going to act like there are 3 different disks, let's say. So again, print this out. There's the first partition. Again, new, primary, take number 2, start at the default sector, plus 100 megabytes. Again, I do p to print. There's my second one. Let's do one more. New, primary. We'll take 3, take the default, and here again we're going to do plus 100 megabytes. Print that out. So we're going to use these 3 in our logical volume demonstration here. Let's say these are 3 different disks. So again, I may approach it would be I would partition the entire disk under one partition just for LVM. So for now though, we have SDB 1, 2, and 3 here, and we'll use these for our demonstration. So I need to, again, write this out to disks. It's been written out, and part probe. Make sure we read the partition table. Now, I wasn't done yet. I actually missed a step here. What did I miss? You guys catch it? The type. So this fdisk SDB again, print, and then we can do the type for the M, identify the, change the display entry type, verify type, change the system ID. So T, take partition number 1, and we'll list the codes out once. But you can see I'm going to do them all as 8E. Now I could have did this during, of course, during the actual fdisk part. So I actually dismissed that. But in any case, you can catch it before here. I can change it. Since it hasn't been formatted with anything yet, they're just blank partitions. So we'll take 8E. If I print now, it's been identified as 8E. So again, and for help, I want to change the type of system ID, which sets the ID right there. So type for 2, 8E, type for 3, 8E, oops, is type for 3, 8E. All right, now if I list it out here. So again, I'm gonna write the table, and I'm gonna part probe again. Now part probe might not be needed here in this case, but don't have to run it again because the ID might be written down as part of the partition itself. So, all right, so undo fdisk-l. You can see I have the 3 partitions here written as LVMs. All right, so now let's create the LVMs. So our first part, of course, is we need to create the physical volume part. And yeah, I got that here. We can look at it. So again, we were file systems, and we're done. First off, our devices again. So we created 3, 1, 2, 3. We did partitions. We're going to consider them 3 disks, let's say. And we need to create our physical volume. So we're going to select which devices go into it. So for us, we're going to go ahead and put all 3 into one physical volume. And then we're going to create a volume group from that too. So PV create is our command. And we basically give it a list of our physical volumes. We sort of need to mark these as, flag them as physical volumes to be used. So dev SD B1, dev SDB2, dev SDB3. All right, so successfully created. So it is basically tagged these as used, and we can use them called PV display. And we can display out each one. Now I think we have an existing one already. Wow, okay, that's annoying. All right. So this says that there's an existing logical volume already on the system. And dev SDA2 has that. And it's called VG. And see, it's 15 gigabytes. So ours will be listed here. We can see our created SDB1, 2, and 3. 100 megabytes physical volume size. All right. So now we can create a new volume group. So we can take these physical volumes, put them into, mark them as ready to go into a physical volume, and we create a group of them. So we see here. So we create our PV. Now we need to create a volume group. So again, this is where I can take either a single physical volume or multiple, and then so identify it as used for multiple volume groups. May have a volume group for user data, and now I have one set aside for database. And then from there we create logical volumes, which could map to, we'll see here, map to different file systems. But first off here, let's create a logical volume group. So we use VG create. So before we did PV create, now we use VG create. So we need to give our group a name. We'll call it VG0. I think VG was taken. We'll give it a name here. And then we want to put down what we want to put inside that group. So again, we'll do all 3. Dev SDB1, dev SDB2, and dev SDB3. Okay, we created the 3, but now that volume group has those 3 physical volumes sort of identified for its use. So it's sort of like we're like tagging and bagging these physical disks and saying you're used for this area, this volume group. Again, there's a VG display, and you can see there is VG, which was created originally, and ours is up here. VG0. Scroll bar drive me crazy, so let's do this. VG0. There we go. So there's VG already on the system. This is one we just created. So it's LVM2. It has a VG size of 288 megabytes. Now, I know we have three 100 megabyte disks. You think, well, those should be 300 megabytes. Well, there is some overhead. You pay overhead. There's some overhead tax for volume group use, and that's normal. And we use something called PE size, physical extent size. This is almost like the block size we saw with actual physical disks. So you can grow by physical extents. So we have 72 physical extents. We have 0 allocated, so it's basically free. And it says here free size and free physical extents. There's 72 physical extents available, or 280 megabytes. And then we have this unique ID attached to it. So that's our volume group. So usually what you need to do too is we need to actually now mark this as available. So we have a VG change. We can change stuff. We want to make it -A. So let's do -help here. So we want to identify this as available. Normally you create it, it's sort of like in a draft state. It says I'm here, I'm ready, but I haven't been marked as available yet. If it's not available, logical volumes or LVs can't pull from it. So VG change -A, we want to mark as available, which is yes, and in what volume group? VG0. Now it's active. So we've marked it available or active now. So it's a very important step, and you should do that. Now our last step here. So we created a volume group. Again, we took three, we'll call them physical disks. We took three partitions, ST, B, 1, 2, and 3. We put those into one single physical volume, and we created one volume group from that. And now we're going to create our logical volumes. So, all right, so let's create some logical volumes here. So let's create one for database use. And we'll mount it, and we'll actually do some stuff with it. So LV create is our command. And we want to create it by a certain size. Now LV create, it has a long help for it. Identify the length of your volume group. -L, hit uppercase L. Actually, there's this scroll bar. I'm not found the scroll bar here. All right. So we want to say how big we want. Do we want to use physical extent sizes or not? So yeah, let's just give it to you. So LV create, we can do the display of the volume group and say it has 72 physical extents as so much size per extent, and do the math, or you can do this. -uppercase L. We can identify a logical size. That's what L does. Let's say 128 megabytes. Then we want to give it -N a name. We're going to call it data1. This is just a label we're going to give it. It's seen in the LV display. We'll see here in a second. And then we'll say where we're going to pull this from. Well, we have that VG0 we created, VG0 from these physical volumes, or this physical volume. So we're going to pull this 120 megabytes from VG0. And it's created. So that we do LV display. We will see, we have to swap in root here. Let's go into show ours. LV display data1. Oops. There we go. All right. So in volume group 0, display any logical volumes. And we have 1 right now. And if we created more, you saw before, it shows all of them. So what we have here is, this is the name we gave it. It came from volume group 0. We took 128 megabytes, which was 2 segments or 32 logical extents there. And then some other information, block device and so on. It's available. It's for read-write, which is good. You can create read-only logical volumes if need be. But more important is this right here, this logical volume path. It's sort of like, this is how we see this. This is actually, I think this is a disk now. Dev VG0 data 1 is now out there. Now, because it's there, we need to format it still. So it doesn't mean it's ready for use, but it is there, it is available. Now, I won't open fdisk-L, only shows up in the LV display. So we do need to do mmkfs, ext4, let's use that, and we'll use dev vg0 data 1. So again, we still need to format it, but now we actually have some sort of disk that's been pulled out. So we have this created. Now we see it formatted as we would any other disk. And now we can mount this. Mount dev vg0 data 1 to data. If I do fdisk or df-h, we can see now our 120. Again, there's a little bit of overhead there, but it's normal 127 megabytes has been allocated for dev vg0 and /data. I got this also mapped, so we got to map that one. You mount. Run everything off data. Clean up a little bit there. All right. So again, after the LVMs, the logical volume has been created, we mount it like as we would any disk. Our VG display, our LV display will tell us the path of that, as we saw here. And this is how we reference this new logical volume, this right here. And we saw we mounted it to a file system. There you go. And there's a mount command. Again, mount device to partition or directory. And it's there. It's mounted. Now let's say that has filled up. Let's think about logical volumes now. So this /data has gotten too full. It's almost 95%, 98%. Alarm bells are going off. I can grow it now. I can actually pull from any existing space in my volume group and pull it into this logical volume. If the volume group's getting full, I can add a new physical volume into it. So you can see with this chain here, we can create, actually add more physical drives, add them to the volume group. Now we have the space available, and we can grow a partition that way. So let's go and grow this. So let's say it's gotten too big. We want to add some more space. So more importantly is VG display, VG0. We can see we've allocated 32 extents for 120 megabytes. Let's say again, that is going to, we saw that was going to our new data 1, our data right there. So we want to grow this. We have space to pull from. So let's say we want to pull 20 megabytes. So we have available space here. So we're good. There's no need to go back and create more physical volumes. So we're going to pull from VG0. So our command is LV extend. And again, we use the -L, uppercase L, for logical. So we're telling it we want to do plus. If you do lowercase L, you got to use the number of extents. And I don't want to go and do that math. So plus 20 megabytes. And then what I want to grow, I want to grow dev VG 0 data 1. And there you go. Now, we're not done yet though, but we have actually now took 20 megabytes from the existing volume group. It was already in VG0, which it was there, and we grew it, data 1 to 148 megabytes when it was 120 megabytes. Now still, if you do df-h, it still shows 127 here. So we need to do one more step, and that is to do resize to fs. Resize to fs. So we need to sort of tell the file system, hey, resize it. resize yourself. And basically, we just do this dev vg0 data 1 again. So that's now 20 blocks long. Now -h. Now it's 126 megabytes. So LV extend dash uppercase L, how much you want to extend it by, plus 20G, 20M, 20K, and then what we want to actually extend the volume group. And then when we're done, we got to do resize 2fs, and then we actually identify that logical volume to resize. So you can see now we grew it. So you can see there's a lot of advantages to this. This is really the way to work. More complex systems are more dynamic. So again, if we have a web server running and /var www is mapped to a volume group and our web content's gotten too big, our database, let's say for example, we can literally pull from free disk and grow it. We're out of disks, we can go buy a new disk, plug it into the system, add it to the PV, add that PV into our volume group, and then voila, we're off and running again. So logical volume is really what you're going to see now. It is sort of the premier way to work with disks, and even now I have a Pop! OS laptop over here. It's running LVM. So that's a quick review of that, and hope you enjoyed it.